So I'll start with talking about myself. So I'm from Kyiv, from Ukraine. Near my house, I have a nuclear reactor. It's not that everyone in Ukraine have a nuclear reactor near their house, but that's lucky me. I live in the prospect of science. So we have our own scientific nuclear reactor. So not that one that was filmed and used in the TV series Chernobyl, but at least some parts were shot just directly at my house. So yeah, come to Ukraine. It's very nice and interesting place to live, to be. And I'm doing consulting in JavaScript. I do open source development, and I used to be a just developer, but then I found out that I really like to write tests, and my mission that I see that I want to bring some joy into testing process, because I don't see that people love the job what they're doing. So writing meaningful tests, writing easy to follow tests, that's what I'm trying to make with my open source work. And what I don't like in tests, especially when those tests are showed to me by other people, so especially when those tests are written in JavaScript. Well, usually I found out that code written for the test may end up like this. So it's really painful to read this. I don't know the emotion of a person who wrote this code, but probably he didn't feel some joy. And probably it's painful even for the computer to execute this code. And what's wrong with this code? Just everything, because you don't really have a clue what it does. But in tests, what we should always know, what is executed, we need some full control of the execution. We need predictability. And this code isn't predictable at all because, yeah, you just can't read it. Some of you may say that, hey, this guy just was using the old JavaScript version. Now you can use async await and remove these promises. If some await won't work, just add more awaits, and this code can be cleaner. But probably no. It was written badly in the very beginning. So what can we do to solve this problem of a bad code? We can use Cucumber with protractor, and now these ugly lines of code will be transformed into this nice Cucumber report, so everyone could read, your managers could read. Technically, we didn't change any line in the code. We just placed it under the Cucumber steps. So what we did actually was just putting the garbage so no one would see it. And if you see the vacancies like, hey, we need an engineer with protractor plus Cucumber experience, probably what they do usually is they hiding shit under the Cucumber steps. And that's another problem. So even if your steps look really nice and cool, just read the actual code which is being executed to check if the test is actually good enough. So the problem in those code I showed is the over-engineering. So first of all, when we develop tests, we are too focused on browser control. And this is the deepest mistake in mindset of people who come from Java, maybe, who started to learn programming from the browser controlling, who doesn't know any data structures. They just want to control browser. They have API of browser, and they are focused on automating a test and not to write a test automation. Yeah, so not to make this test clean from start. So, and this guy who wrote this code was very passionate and didn't think of how the same result can be achieved in a more elegant and clean way. Because we are too focused on browser control, we are really stick to the tools we use. Protractor, Cypress, WebDriver.io. So we look deep into these tools. We take some very strange APIs, we use them, and by using them constantly in tests, we forgot about maybe it wasn't so, this tool wasn't for this kind of job. Maybe we could search for alternatives. So maybe we can do this a better way. So we still do go into the technical details of implementation and not trying to focus on our test. And in JavaScript, we all have to deal with asynchronity and promises. And yeah, as I said, if you don't know how to do it, just add await to every line you wrote. Probably it will work. If it doesn't work, add more awaits, and then it probably will work, yeah. So different tools solve this problem of asynchronity and promises by their own ways. I will go more into details about promises on my talk tomorrow, where I will go through all these tools and comparing them one by one. How do they solve this and this and this? And asynchronity is one of the problems that increase code complexity, that can just make your test very flaky and just sometimes blow your mind when you don't understand why the test has finished 10 minutes before it should actually do. My solution to this: stop focusing on tools, stop focusing on browser control. Do not ever care how it will be executed, because what I want is simple instruction. So when I have a browser, I just want to say, open me please this page. So then we just state, yeah, there is some field username, just put in a name into it. Yeah, it's so simple. Click. So yeah, this is like 3 basic actions you always want to have. And the last one is to perform some assertions like see some text, see some element. No more than that. So usually we do not need this over engineering. We probably need just like a limited, simple set of actions, very flexible, but very limited. So this set of actions is not so big, really. And when we go and make a test to follow these actions, and we find out that we are just describing our actions. We are building a user scenario, and the test is the same as we read as we execute. And again, at this moment, we don't really care how this test is executed. So probably it can be handled by browser, because we didn't ask browser to do what it can't. It really looked good from a start. But how will you write a complex text if you have just a limited set of actions? And it appears that you are absolutely fine writing very complex tests. So this is the code from one of my projects, and as you see, it's a page object is used. The click is very explicit, but still we can use CSS locators. We can use some JavaScript code. So I started with a simple scenario. Then I refactored it, but still I didn't lose the readability for this code. So line by line, it is executed. And I won't tell how it is executed in which browser, because this code is absolutely agnostic to a tool it will be executed. But we will go see this in more slides. Yeah, so how it is executed? In WebDriver, in Cypress, in TestCafe, in Puppeteer? Well, we can choose any of those. Technically except Cypress for now, but actually, because we didn't declare any dependency on the tool, we can use anything. So this was the code from the framework I developed, CodeceptJS. So as you already understood, the main motivation is not to build another Cypress WebDriver IO tool, but something that can unite them under one same syntax. So it's end-to-end testing framework. It already includes all those methods I've shown to you, so most of the time you don't need to extend it, just download. So maybe you didn't hear of CodeceptJS because I am the only person and no big company stays behind me. So the only company that works on CodeceptJS is my company, and I gain money from CodeceptJS by making consulting, trainings, and so on. So that's my daily job, I would say. And again, it's very hard to promote framework if you are not behind the big company like Google, like Cypress, and so on. So, but still, we are getting growing. So as you have seen, that the test looks like this, where I describe my actions. When I need, I can use CSS locators. When I will use semantic locators, for instance, for a field, probably have a placeholder or a label. Well, why not to use this to locate an element? Probably this approach will be a bit slower than selecting an element directly by CSS locator. But we gain much more than few milliseconds in speed. So whenever I can, I try to stick to the text elements on the page. So it probably won't work for the when you test multilingual site. But if you don't do it, or if you want to test only one version of a site, it's really nice to have your tests looking like this, because it really saves your time in understanding, fixing tests, maintaining, debugging it. So yeah, the code is really nice, and it's very limited. You won't be able to write something like in the first slide with the code, but you can probably try to write bad code with this one, but you will be very limited in what you can do. So by splitting this into steps, like Cucumber does, we see that execution step by step. So you won't see like blank screen and then, oops, I failed somewhere. No, you see a step-by-step execution, and when something happens, you can easily figure out what it did and where are you at. So here's the idea that CodeceptJS lies on top of all other frameworks. So the test cafe is also added here. So WebDriver, Protractor, Nightmare, Puppeteer, Test Cafe, and we can go beyond this to Appium and Detox for mobile testing. And all of them are united under the same API. So I remember one time for a company in Germany, I conducted a workshop for CodeceptJS, and half of audience were using WebDriver IO, half were using Puppeteer, and we still had the same workshop. So there were different teams, they had different requirements, but it was very easy for a company to educate people just to use CodeceptJS, and then they can easily switch between teams. And there was no problem like, we use this here, we use this here. It's very easy to migrate from one to another. So I won't say that tests written for WebDriver IO will work in Puppeteer without any change. These engines are quite different. They can be edge cases where they behave differently. But because the syntax is the same, you can easily migrate from one to another. So that's the idea of architecture. So what does it solve? So in JavaScript, what I have seen for these years, that new tools are coming. So a few years ago, there was no Puppeteer, but when it appeared, it just blew minds of testers, developers. Everyone wanted to start using Puppeteer. Then became Cypress. There was Test Cafe. So probably tomorrow we will have like another maybe some Cypress killer, so some new, more cool framework, or again maybe some of the current tools which we use will get an upgrade. Like Protractor will upgrade from 5 version to 6. What you would regularly do with this? Well, you will probably need to rewrite your test from scratch, because the changes will be really dramatic. The similar situation happened with WebDriver IO this December. They published an upgrade from 4 to 5, and lots of current setups were broken because they had to migrate all the code, and it was pretty similar but still different. And we, under CodeceptJS, we did this migration in 3 days because all we had to migrate is all this limited number of steps. So people who had tests with CodeceptJS and WebDriver.io got a free upgrade to WebDriver.io 5. So for all others who were using WebDriver.io natively, well, they won't. They have spent really long nights fixing their code to upgrade. So, by the way, we have WebDriver.io maintainer Christian Broman here. So I don't see him, but he is somewhere. Or, anyway, WebDriver is really great framework, and the upgrade was brought lots of new features and very nice syntax. So far, I love WebDriver.io, and upgrade is something that happens to all frameworks. So it wasn't a minus of WebDriver, to be honest. But yeah, it's a very cool approach when you are not limited to a library. Okay, so when we discovered how to write your tests, how to execute them, we find out that world of testing is not as simple as, hey browser, please open me this page, click me here, and I want to see something. We have to deal with lots of problems, and the world isn't getting simpler and simpler. So single-page applications add more complexity to the DOM. The browsers executing more and more stuff, workers, or all this PVA, and tests are not reliable. So today we can't even say when page are loaded completely because there are no such terms as that page loaded. In single page application, page can be in transition state for all the time. So we still need to deal with flackiness, and there are no feedback like, hey application, please say me, are you ready for usage? Most of applications won't tell you, especially React application, Angular application. So flaky actions, flaky locators. At some cases, we have to deal with applications that are not designed to be tested at all. So we need to build complex XPaths to find the elements on that page. We need to debug all this stuff. We need to produce meaningful reports in the end. And data management. No, actually, not too many people actually talk about this in tests, but this is a big problem. That's actually from where you start. If you want to change something in the system, you need to prepare this data in a system. How would you do it? Definitely not through the web interface. That would be a disaster. So you see, even we added this cool architecture with all the tools supported, we still have lots of problems to solve. And it appears that by leveraging this architecture, it's really simpler to solve this problem for all the tools underneath, and have all this focus on the actual testing problems. So for instance, what in CodeceptJS we have for flaky steps? Lots of stuff. So first of all, I really love the auto retry plugin. It's the most lazy approach you have. Just say, okay, if this step failed, just retry it a few times. I don't care how it worked. If you know exactly at this point the page maybe have flackily, you can put the explicit retry command, disable auto retry plugin, put a retry, and lots of people are comfortable with this because the tests behave more explicitly. And traditional Selenium wait commands, sure, you can use them, especially if you know exactly what you are waiting for, like changing URL, the appearance of pop-up. Sure, you can use wait. So all those three combined together, and you won't need to think about flackiness of steps. So what we do with flaky locators? As I said, when you go and test a project which are absolutely not prepared for it, for instance, it's minified React application where no classes, no IDs, some links and buttons are made as div, you can go crazy writing locators for such application. But if we focus on a text elements, on semantic elements on page, it appears that it will be much easier to find right element and use them. So that's what we propose from start. So use semantic elements. That's not just because of readability. It's also about stability, because button texts won't be changed as often as maybe its classes or look. And even if a button text is changed and you see, okay, I couldn't find the button login, you just open a page, oh yeah, it's now called sign in. You don't need to even look into browser. You can look on the screenshot. And from the screenshot, you see that the button text has changed. You easily update the test, and it will go on. So taking more semantics into the code, not just position in XPath or CSS, really brings more stability to tests. So if you know that this class or this position will be used everywhere, so you can use CSS and XPath, and actually you can combine all those approaches, and it's up to you to find which elements are stable or not. So I do not usually write XPath. When I need to write XPath, I find myself Googling how to write in, trying different combinations. And XPath doesn't bring readability to your code. That's why we have some simple XPath builder. But this XPath builder is really really nice in terms of showing what is meant to be done here. What are we searching for? So this small command generates XPath, where we just describe, okay, I need in a table some link, which will be edit button. Probably I should have added at first or second position. So it's really easy to write and have an XPath as an output. So it will be transformed to XPath. So again, to make your test look nice, focus on user action. Don't show some complicated details when you really need to take a browser control, for instance, to pick a day in calendar, to draw something on canvas. You can hide this behind the step and show it as a usable step. But using semantic elements is also adds some bonus in terms of readability. And if your scenario is simple, well, that's really great. So yeah, again, the example of a code. We can, if our test is very readable, we can easily move some parts to page objects. We can add variables, not a big deal here. So it can grow and grow and grow and be more and more complicated and still readable. If you still need Cucumber, but Cucumber not to hide the sheet under the carpet, but Cucumber to write real BDD, we have a full Cucumber integration. So not many frameworks can say that, okay, we are fully integrated with Cucumber. And there are some reasons, because Cucumber provides their own engine to write the tests, and because the tools like Cypress or TestCafe execute tests on their own, they can be combined really well. So I know that they can be combined really well because I tried for CodeceptJS, then I had to rewrite everything, and I know how hard it is to make a smooth Cucumber integration into a custom testing framework, but I did it and it really works. So on top of the steps that you have seen, you can add this meta step as in Cucumber. So you have both business scenarios and interface steps working together. So yeah, I would recommend to use this Cucumber for the tests that are really following business scenarios. So do not write Cucumber scenarios for regression tests. It's not a business value, it's a bug. But for feature, yeah, it would be strange to start writing a test for a bug, starting with the word feature, as it is in Cucumber. So have a limited set of business valuable high priority tests, write them in Cucumber manner, make the discussion across QA teams, development teams, management teams, and put all other tests, regression tests, with a traditional, in a traditional step-by-step style. You can combine them, mix both, and yeah, it's even more fluent BDD than you would do with Cucumber itself. So it's not too much regression tests will be in Cucumber scenarios. So promises, asynchronity. Oh, await. So how do we solve the problem with promises? So again, we combine both approaches, saving promises into the global store, like it does Protractor, like it does Cypress, I think, and await. So I don't like the approach where you should put await on each line, even it's more explicit, because I am getting tired just copy-pasting my code. So we ask users to use await only when it is needed, and it's needed only when we need to pause execution, take some data from the browser, and use this data in the next steps. So all such commands are started with grab prefix, and before grab, we should put this await to pause the execution. And what I like in the development mode that we can just open a page and ask CodeceptJS to pause execution. So then execution is paused, and I am inside this terminal where I can type in my commands. So I'm just typing in. Okay, this command worked. This command worked too. And this command, oops, I need to try it again. Oh, now it's better. So after you just typing commands, and then closing the session, all successful commands are saved to file. What you need to do is just copy this from this file to your test, and hooray, you have a test with when the browser was executed only once. So yeah, it's very easy and joyful to write such tests. Just type in commands, and successful commands fill your test. The same can be used for debugging. If your test has failed, add the pause command in the end, and instead of closing the browser in the end, you will see this terminal. You will see can type in commands. Okay, if this locator didn't work, maybe I can try with this one and maybe with this one, and upgrade your test to pass. And yeah, we have automatic screenshots, but it's not a big feature. Coming to data management. What we propose for data management is to use APIs, existing APIs of applications. So nowadays, you either use a REST API or GraphQL to manage your data. So if you need to remove products from your system or create some products from a system, don't do it through the web interface. It's so long, it's so flaky. Ask your API to create them for you, and you can do it very easily. So what's behind these two commands? Behind them, there are rules for data generation. So I say a product should consist with a name. Name is a random string. Then some ID, it's random ID. So I provide these rules from data generation. Then I have REST API endpoint to create it. And after test passes, I use the IDs of those created items to delete this data from the database to clean it up. So each test can create the data of its own, remove it, and you need only 2 lines of code to do this. Yeah, that's all. Parallel execution, sure, we have it, and it supports the latest Node.js workers. It also runs tests not by files, but each test will be executed in each own worker. So I think the only Jest framework works like this to give you a real parallelization. And we also implemented it. So after all, especially after you execute a test in parallel, you need to have a good reporting. So we have the Allure integration, which is really great. Especially I like in Allure that if you run tests in parallel, each test generated its own report. Allure can aggregate these reports and show them in this nice interface. So Allure is open source and very beautiful self-hosted solution. So this is a small video of how it works. Oh, sorry, is this video showing? Do we have a time for a short video? Okay, yeah, it started. So just to show you how to, so everything starts with this meta object I, which delegates actual commands to the testing frameworks like WebDriver or Puppeteer. So all assertions start with a C prefix. This is another commonly used command to fill some fields. So, for key press, we can use the standard key name, so it's not a big deal. But the most funny part starts when I will type in pause, and I will show how the execution will work here. So at this point, now I don't know what to write next, so I use pause and execute the test. So for this configuration, the project is starting with Puppeteer. You see that, I hope all of you see these steps in the bottom, so all steps passed, and then the interactive shell started, and we can type in commands. Oh, I think video is a bit cut. So I'm typing in commands. I checked that CodeceptJS is on the website, and probably that's it. So yeah, I clicked something like to move to the repository, checks for the text. So I can append the test on the fly. Okay. So again, to summarize, CodeceptJS is a meta framework. So technically, it can work with any other frameworks, but adding unified solutions for testing on top of them. So as you see, we solve such problems like data management. No one solves this. We solve, like, we have page objects, we have XPath. So whatever test engineer needs. So we are not limiting you. And yeah, if you use it, it's really simplifies your life, debugging, and saves your time on writing good tests. So thank you very much. The Concept.io, go to it, install it, use it, send feedback in Slack. So thank you.